Okay, last video. Volume by cross sections, and when we say cross sections that are not circles. And I spoke about this in class today. Alright, so we will be using the area of other known figures. So area of a square, side squared, area of a rectangle, we know length times width, base times height, circle, pi r squared, but this is our disk and washer method. Triangles, for right triangles, 1/2 base times height. Alright, we'll talk about the next two in class, but we know the area of a semicircle would be pi r squared over 2. But when we do one of these, I will show you. The radius comes from the difference of the functions, so we actually have to cut that radius in half and then square it. So when you're given a problem for area where cross sections are semicircles, it would actually be pi r squared over 8. Alright, equilateral triangles, that's square root of 3 over 4 times side squared. Alright, so this is from your book. You'll just want to jot this down. And perpendicular to the x or y axis is very important because it tells you what to integrate with respect to. So if you think of disks and washers, our formula was just the integral of pi r squared with respect to x or y. So now all we're doing, this was just the area of a circle. So volumes of cross sections is just the integral of whatever the area formula is. And again, with respect to x and y axis, just determines what you integrate with respect to. Find the volume of the solid bounded by these two functions, x equals 0. Cross sections perpendicular to the x-axis are equilateral triangles. So before we set anything up, area of an equilateral triangle is square root of 3 over 4, side squared. They're perpendicular to the x-axis, so I'm integrating with respect to x. Alright, square root of 3 over 4 is just a constant. So now we have to determine what the side of the triangle is. And let's look real quickly at a graph. So f of x, y-intercept of 1, slope of -1/2. So this would be f of x. G of x, y-intercept of -1 with a positive slope. And then x equals 0, of course, is the y-axis. So we're looking at this region. Now we're not revolving it about an axis, and I'll show you the picture next, but what you have to think of to make this a three-dimensional region, equilateral triangles would create the solid. So it's like equilateral triangles would be coming from this boundary. So where do the side of those triangles come from? The side of those triangles is just the difference of the two functions. So the side that we're squaring would be f of x minus g of x. And we'll simplify all this algebraically before integrating it. Distributing the negative. So the side of the equilateral triangle would just now be 2 minus x. Okay, so this figure is in your book. Here's f of x. This is what we drew. Here's g of x. And then the solid that's formed, these cross sections are equilateral triangles. So notice that the side we're looking at, that was the difference of the functions. So volume, square root of 3 over 4, integral of the side squared. Okay, now we need our boundaries. So where do boundaries come from? We're going to set our two functions equal to each other. Now you can see from the graph that the boundaries of the region are going to be 0 and 2. If we, what is it? 1 minus x over 2. minus x, no, plus x, so then x equals 2. And x equals 0 was given as one of the boundaries. Now if we want to make a u substitution for this, which is okay, we just have to make sure we introduce the negative out front. So negative root 3 over 4, u cubed over 3, from 0 to 2. This would be 2 minus x cubed over 3. Okay, so for homework, evaluate the integral. And your resulting answer would be the volume of this solid here. Find the volume of the solid whose base is bounded by the line x plus 1 and the quadratic x squared minus 1. Cross sections perpendicular to the x-axis are squares. So it would be the integral of the area of a square, side squared, with respect to x. Alright, our boundaries. Set the functions equal to each other. And we get x is equal to 2 and negative 1. To get the side is just going to be the difference of the two functions. And if you think about what the graph looks like, x squared minus 1, and then x plus 1, right, between negative 1 and 2, then what would the side of the region be? The line minus the parabola. Distributing the negative, negative x squared plus x plus 2. So now to find the volume, the integral from negative 1 to 2, negative x squared plus x plus 2, quantity squared, because that's just the side, then we have to square the region. Square the side, rather. Okay. We'll finish that in class together, because it's squaring a trinomial. Alright, and lastly, find the volume of the solid whose base is same boundaries, the line and the quadratic. Cross sections perpendicular to the x-axis are rectangles of height 1. What's a rectangle? Base times height. We're integrating with respect to x. So it would be the integral of base. We're given that the height is 1. And what's the base? That's just the side that we determined in the previous problem. So it would be the integral of negative x squared plus x plus 2. Same boundaries from negative 1 to 2. And we will integrate this one. So between negative 1 and 2, negative 8/3 plus 2 plus 4 minus 1/3. Negative 8/3 minus 1/3, that gives me negative 9/3, which is negative 3. 6 plus 2 is 8 minus a half, so that's 5 minus a half, which is 4 1/2. So 9/2 for the volume. Okay, for those of you that said you won't be in class tomorrow, Wednesday, the 20th, what we'll be working on from the packet, page 468, numbers 72 and 74. And we'll also be taking the quiz, so you will come to find me Thursday at lunch in W12. You have to take your quiz for anybody who won't be in class tomorrow. Have a nice night.